Greetings to all, and welcome to another fascinating journey into the realms of our planet. Today, we delve into the marvel that is Earth's atmosphere. This invisible shield, an intricate blend of gases, wraps around our world, creating the life-sustaining conditions we so often take for granted. It's a delicate balance, with nitrogen making up roughly 78%, oxygen close to 21%, and a mix of argon, carbon dioxide, and other trace gases filling in the rest. And let's not forget water vapor, which, though it may only make up about 1% of the air at sea level, plays a crucial role in our weather systems. This grand tapestry of gases is not only vital for our survival, but it also sets us apart in the vast universe. If you're as captivated by the wonders of our world as we are, make sure to subscribe and share the content. So buckle up as we take a thrilling ride through the layers of Earth's atmosphere. Our journey begins about 4.6 billion years ago, with the birth of our planet Earth. At this time, the Earth was a hot, molten mass, bombarded by asteroids and comets. This intense heat and constant bombardment led to the formation of Earth's first atmosphere, which was primarily composed of light gases like hydrogen and helium, that were present in the original solar nebula from which the Sun and the planets formed. However, this initial atmosphere was not stable. The Earth's gravity was not strong enough to hold on to these light gases, and much of it was lost to space. This led to a period of atmospheric transition. As the Earth cooled, volcanic activity became widespread, leading to what we call the second atmosphere. This was an atmosphere enriched with volcanic gases such as water vapor, carbon dioxide, and nitrogen. But the story doesn't end there. The third and current atmosphere began to emerge around 2.4 billion years ago with the development of photosynthetic organisms. These tiny life forms, like cyanobacteria, started to use sunlight to convert carbon dioxide and water into oxygen and glucose, a process known as photosynthesis. Over hundreds of millions of years, these organisms released enough oxygen into the atmosphere to create an environment suitable for more complex life. In this way, the Earth's atmosphere evolved from a volatile mixture of gases into a stable, life-sustaining environment. This transformation was not a quick process, but rather a gradual evolution over billions of years, shaped by geological and biological forces. Thus, from a hostile environment, Earth's atmosphere evolved into a life-sustaining blanket. But what makes Earth's atmosphere so special amidst a universe of planets? Well, let's take a cosmic journey, shall we? Imagine we're hopping from one planet to another, comparing atmospheres. As we travel through our solar system, we would quickly realize that Earth is quite the exception rather than the rule. Let's start with our closest neighbor, Mars. It has a thin atmosphere, composed mostly of carbon dioxide, with traces of nitrogen and argon. But what's missing? Oxygen. And without oxygen, life as we know it can't exist. Then we have Venus, often referred to as Earth's twin due to its similar size. But don't let that fool you. Its atmosphere is incredibly dense and almost entirely made up of carbon dioxide with clouds of sulfuric acid. Not exactly a hospitable environment, right? And what about the giant gas planets like Jupiter and Saturn? Their atmospheres are mostly hydrogen and helium, the same elements that make up our Sun. Fascinating, but again, not suitable for life as we know it. Now, let's return home to Earth. Our atmosphere is a cocktail of gases, primarily nitrogen and oxygen, with traces of argon, carbon dioxide, and others. But it's not just about the ingredients, it's also about the proportions. Our atmosphere has just the right amount of these gases to support life. And that's not all. Earth's atmosphere has a unique feature. It can absorb harmful solar radiation. This protective shield prevents most of the sun's damaging ultraviolet light from reaching the surface, making life possible. Also, the Earth's atmosphere has a mass of about 5 quintillion 150 quadrillion kilograms, with 3/4 of it within 11 kilometers of the surface. As we ascend, the atmosphere becomes thinner, creating different layers, each with its own characteristics, which we'll explore in the next scene. Indeed, Earth stands out as a beacon of life in the vast expanse of space. We're not saying that life can't exist elsewhere, but so far, our planet's atmosphere is the only one we know that supports the rich diversity of life we see around us. Now that we've marveled at the uniqueness of our atmosphere, let's delve deeper into its composition. Our atmosphere is a beautifully layered realm, each with its own character and purpose. Let's explore these layers, from the one we're most familiar with, up to the edge of space. Firstly, we have the troposphere, the layer closest to Earth, where we live, breathe, and where weather phenomena take place. This layer extends around 7 miles high and contains most of our planet's breathable air. Above the troposphere, we find the stratosphere, stretching up to 31 miles from Earth's surface. This layer is home to the ozone layer, a shield of gas that protects us from harmful solar radiation. It's also where commercial airplanes fly to avoid turbulent weather of the troposphere. Next up, we ascend into the mesosphere, reaching up to 53 miles above the Earth. The mesosphere is the layer where most meteors burn up upon entering the atmosphere, creating shooting stars. Further still, we enter the thermosphere, extending up to 400 miles high. Despite its name suggesting heat, this layer has a wide range of temperatures, from extremely hot to incredibly cold, depending on solar activity. This is also the layer where the northern and southern lights occur due to the interaction of solar particles with gases in the atmosphere. Finally, we reach the exosphere, the outermost layer that gradually fades into the vacuum of space. Although it's incredibly thin, this layer is vast, extending up to 6,000 miles above the Earth. Here, atoms and molecules escape into space, and satellites orbit our planet. So you see, our atmosphere is not just the air we breathe, it's a complex multi-layered shield, protecting us from space's harsh conditions, providing a stable environment for life, and adding a dash of celestial spectacle for our viewing pleasure. Each layer of our atmosphere plays a crucial role in making Earth the haven for life that it is. As our journey comes to an end, let's recap the wonders we've discovered. We embarked on a voyage through time to witness the birth of Earth's atmosphere, learning how it evolved over billions of years to become the life-sustaining blanket it is today. We marveled at its uniqueness, a precious gem in the cosmos, unlike any other planet's atmosphere. We then ascended through the atmospheric layers, from the weather-making troposphere to the boundary-pushing exosphere. Each layer, with its distinct characteristics, plays a vital role in maintaining the balance that allows life to flourish on our planet. The atmosphere is more than just a layer of gas. It's a protective shield, a climate controller, and the breath of life itself. It's a testament to the intricate and delicate balance of nature. So the next time you take a breath or gaze at the sky, remember, it's all thanks to our incredible atmosphere. Thank you for joining us on this journey. Remember, the air we breathe, the sky we gaze upon, all exist thanks to our incredible atmosphere. Until next time, keep exploring.